Hello and welcome to today's video. Today's video is on magnetic field along the axis of a circular coil carrying current experiment in the virtual lab. So in this experiment, we will perform the, this experiment for the various current, and for before that, let's go with the theory. So in the theory part, we can have the aim, the apparatus, the theory, where it is given that when there is a current carrying conductor, you can experience one can experience of magnetic field at some distance r. So that magnetic field is dependent on that current, the element, the length of the element, the psi theta, that angle, and obviously the distance between that point and the current carrying conductor. Now here we have some well-known constant and which has some values like this. So this is our ultimate equation for the magnetic field. Now let's see this diagram. In this diagram, this B equation is given by this mu 0 Ni divided by 2 r square by x square plus r square to the power 3 by 2, where this each term has its own importance, like suppose for the n, it is the number of turns in the coil, I is the current, r square is the radius of the coil, x square is the distance from the center of the coil to the point of consideration. Now let's go to the apparatus. We have this apparatus. This is the magnetic needle. This is the coil of of n turns. This is the commutator. So the commutator on, this is the ammeter, this is the rheostat, key, and the battery. Let's go back to the procedure. In the procedure part, before describing how to do that experiment, let's section this pitch figure. So this is along the x-axis, this scale. This is the z-axis or the z-axis. The magnetic needle is now kept here, and this is the coil of consideration, who have the n numbers of turns. Now you can see this is in this circular current carrying conductor in the coil. The plane of the coil is along the z direction, and the plane of the scale is along the x direction. So we can move this coil along the rectangular wooden board. So here in the experiment, this is given that it has 5 to 50 turns, but while you go to the simulator, it won't give you the 5 to 50 turns. I will show you later. So this is the coil C, and having diameter about 10 centimeters, and obviously we can change the diameters also. This is the rheostat part, this is the key, this is our battery, the ammeter part. Now here the procedure for doing the real lab, it is given here to find the magnetic field. So let me describe one by one. So what we have, actually we have a table for the, you will find a table for your reference. So in this table, anyone can find what to do actually. So let's go back to the simulator. So in the simulator part, you can see after keeping it in full screen mode, so we have to go for the initial adjustment. So before the initial adjustment, you can see if you don't have the initial adjustment, you can't enable all these things. So let's zoom the compass, rotate it until it will come at 90-90. So I'm just rotating it until it comes 90-90. Yes, now while when it is coming at 1990, now it is enabled. Now I'm just moving this one till when this needle will touch the zero. Here also it will zero. So let me do it. So it's 0 0, show normal. Now we will follow this connection. So this is the coil. First of all, we will connect this two, 1 and 2. So we have this one connected with this and this one. Now I will connect this two, this ammeter end, the negative end of the ammeter, and the rheostat end connected. These four are connected. Now I will connected this ammeter with the battery, negative part with the key, and one part will go to the rheostat. Now my insert key option is now enabled. So while I will click the insert option, the key will be inserted. Now you can see the current is showing, current value is showing. Now everything is enabled now. Now what we have, we can choose any type of things from here. So for example, the number of turns of the coil is given as, is actually starting from 10 to 45, as I have mentioned earlier in that procedure section. You could find that it is given as say is 5 to 50 turns, but in actual case it is actually 10 to 45. So let's keep it at 25. Okay, so radius is actually 5 to 10, so I'm keeping it at 7.5. The compass position is 0 here, that means it is exactly center. Now if I move this one, this towards right, that means it is towards right in my case, in this one, in this case, but it is actually moving in that side, so you have to keep it in mind. So this should be visualized properly. So this is my negative distance. So let's, for example, the negative distance, I am taking this negative as negative x, and this positive as positive x. So let me keep it at 0. So this is my positive x direction, this is my positive negative x direction. So for the better understanding, so this is my negative, this is my positive x axis. Let's check again. So I'm going to the positive x direction. See, this is going along the positive x and this is going along the negative x. So let's keep it at minus plus 5. This is my x position. Now I will zoom the compass. Now you can see this is somewhere 74, yeah, 74, 75, 74, 75. So let's adjust the rheostat value so that you can adjust it for a value for deflection of 30, in between 30 to 60. So I am keeping it at 30. So this is 30, you can see this is 30, but this is not 30. So whatever it's showing, you have to keep the, you have to take the actual value. If it is showing 31, you have to take the 31 value. You can't actually round figure it. If it is showing 31, you have to keep it 31. So this is rheostat adjusted 29. So what to do with this value, I'm showing you. So keep this radius as 7.5. Don't actually do anything with this thing. So go to the show normal. You can see the current is here. This is 0.172, and if I zoom the compass, it's showing 30 here and 31 here. Now I have another option. It's called the reverse the current. Now if I go the show normal position, I have an option to reverse the current. Here is the commutator key. if I put this commutator key on another side, what will happen if I put here only, the current direction will change actually. The different direction of the current will give us a different direction of the magnetic field. Hence, we will get a different deflection. Let me show you. So if I reverse the current, see what is happening. Just because of the magnetic field is reversed, the deflection will be reversed. So let me be with that value. I'm going for the show normal. Now let's go to this value. So you can see I have distance from the center x, deflection with the compass box on the left side, deflection with compass box on the right side. I have another column for the mean bx, and ultimately this is the b0. Now coming to this distance part, so we already have the distance as 5 centimeter. So what we have to do is we have to write 5 here, and if you go for the theta 1, let's go for the theta 1. So if I zoom it, so theta 1 say 30, theta 2 is say 31. So theta 1 is 30, this is 31. Now what is about 33, theta 3 and theta 4? Let's go back and check for the theta 3 and theta 4 by reversing the current. So this is around 30 to 40, that is 31. You can take this is also as 30. So this is 31 and this is 30. So let's go back to this one. So this is also this 30 and 31. So this is the for the one side, this is the plus 5. Now deflection with the compass box on the right side. Now I have the compass box on my right side. Now let's go back. So I have to keep it this 5 as -5. Okay. Now actually I was in that portion, so I didn't reverse that current at that moment. So now I am okay. So this is the 30, this is the 31. Keep it down, go back to this. So this is 30, 31. Similarly, if I reverse the current, it will show me the same value. By reversing the current, this is 31 and 30. So let's go back to this. So we have to keep it. This is 30 and 31. So when we have this all this value for this 5, for the 5 x is equals to 5, we have all the theta value. Then we will all have the mean theta in degrees. We will have a bx. Already the b0 is given. You can easily find out the bx value from the equation given here. Let me show you the equation. So here it is. So I think today this is all for today. So you can easily find out the bx value, and hence the b0 value you can find out by using this bx by tan theta. So you have to complete the set 1 for the current as some value for keeping current constant. The number of turns is n equals to constant. The radius of the circular, this is a constant. So yes, so for that you have to fill all these things. Thank you. And if you want to get one more videos, another videos, please subscribe the channel.